Werkt het al? Werkt het? Nog ergens op klikken. Oh ja, hij werkt. Oh, it works. Oké. Werkt het al? Is er audio? Ja, there was audio. Nog ergens op klikken. Oké, hij werkt. Oh, it works. Oké. Is er audio? Ja, there was. Oh, maybe I want the stream pulled up. No audio. Okay. Set the virtual. Let's wait 2 more minutes. Okay. As you can see, I deleted the ECPC to not spoil anything. This folder. I can't even accidentally spoil it. Ten seconds until it starts. Now the question is, will I do the first problem in Python or C++? Not sure yet. Okay, it's starting. Let's try to find an easy problem. This all looks not so easy. Where's the print hello world problem? Ooh, this looks easy. Ah. Give an n, blah, blah, blah. Okay. Which problem is this? Okay. Elevator, stairs. Okay. Didn't really test it, but should be alright. Accepted. Nice. Within the first minute. Yeah, it's too easy. Is there something else easy here? This looks maybe doable. Bitwise or maximum most x. Okay. This looks a bit annoying. I'll skip it for now. Should be something else easy. This looks okay. So there's only at most 1,000. 1,000 distinct palindromes. So you can kind of do something cheesy maybe. Like go through all the palindromes. You know the plus and minus. Yeah, this is too hard for now. Please give me something easy. Is there anyone in the chat? No. Ooh, this looks easy. Yeah, this is really easy. Okay, let's do this one. So what what is up? B, D, C, T, K, T. All integers. What exactly do we need? So every minute drops by D%. So let's just simulate it, right? In range after T minutes, yeah. 1 T plus 1. So what happens? B minus A equal D. And B less than equal to 0. D is 0. Break. Otherwise, if I mod K is 0, B plus is the other number. Which one? C. B is minimum B 100. Okay. Print battery level. Let's see. For this one, let's test to be sure. It should be correct. Submit it. Accepted. Nice. Okay. There's something easy here. Well, this looks weird. What are they doing? Some trick. Oh, disconnected. Oops. Hopefully it still works. Okay. I think I'm back connected. So a bit of a hiccup. Yeah. Currently just scrolling through. Not really sure. They all don't look that inviting. What's this about? Okay, so the input format is kind of easy, so let's read it. Okay. Just alter the character to any lowercase English character. Okay. How many start the game with that guarantee you win? Okay, so it's some NIM game probably. Yeah, it's definitely a NIM game. And CH is basically the blocking character. This is doable, but maybe you time out in Python, so you need C++. Nice, somebody's watching. Okay, so I will make a template then. It's not auto-completing. No. Okay, template. Let's just start implementing. Multi-test. Read input. This. Then what? Okay, we need to just grab array of gaps in between ch. Okay, let's do that. If si ch gap 0 else gap plus plus. Okay, we have all the gaps. Let's calculate the XOR. Okay, now we want Alice to win, so XOR should end up non-zero. Now we just need to loop over a whole bunch of stuff. So let's loop over all the groups. We will change in this group. Oh yeah, and we also need what if not XOR stays the same. If XOR, so then we also need answer. So then every possible change, okay, we can just do this. Ans plus is x times 25. All characters except ch. Then also we can do answer plus equals n, like just all characters stay the same. That's it. Okay. So now we will change something. So first we'll change something in the group. So we get like this and this. If x XOR y XOR j XOR is not 0, ans plus equal plus plus. Okay, so this is if we change something in the middle of a gap. I think that's everything. Can we do anything else? No, for the rest will not change. Then we can just do this. Then we have the two gaps and we glue them together. GSE plus 1. New. If new XOR GS plus 1. Then we can change this to any character that's not CH, so we do plus 25. And I'll put answer. Please would just work in one try. That would be nice. Oops, still in Python. Oh, wrong answer. So what did I fail to? Now let's just debug it. So the first test case we got correct, so let's just do the second test case. There's one gap, that makes sense. Do we already have too much? Yeah, there's already too much, so this part is wrong. The XOR is currently 3. Wait, so let's just read it again. Loses the game. Guarantee a win. So what I'm saying is we could guarantee win here. Okay, I made a mistake here. It should be times 24 probably. Come on. Too much again. Okay, but now I think this part's correct. So then this is the wrong. Where it goes wrong. Let's see. Okay, just a bug. That's annoying. Still not correct. But we're getting there. So this is staying the same. And then we have n position. Okay, how many strings are distinct strings? So this only counts as one string. Not how many moves, that's annoying. For the rest, that fixes it. Okay, let's just submit. Testing system is there for a reason. Probably I didn't work on the right problem, but it's accepted. Nice. Let's look at standings. I should have worked on age probably. Let's do it now. What is it about? Sorted. maximum number of shifts. Okay, yeah, that makes sense. Why it's solved so much. Probably I want to do it in Python, just because. There's a string, right? Non-decreasing order. Oh, minimum number, that's annoying. Okay, let's see. If h equals greater or equal to 2, print -1. And if h is 0, print 0. Else h is 1. So then we need to find that, and then we need to check. I did make a mistake here. Okay, then we want this to the front. Ans is n, ans is min, ans. Okay, ans is minimum of I and minus I. And ans, okay. 0, -1, 2, 3, 0, nice. Come on, come on, come on. Okay. Yeah, okay, nice. Is there anything solved? Oh. Was that the one I didn't like? Oh, yeah, okay. Maybe I should have paper. Okay, some paper. So what was the problem again? So bitwise OR of their labels is at most x. Okay. So if we have x, then what can we do? We can decide on the one that turns into a 0 or none at all, and then the rest we put ones. Then we need to solve a problem with the subset dp. That's 30 squared. Is that good enough? Probably it is, but it's a bit tight. So how would I do it? Can I do better than 30 squared? This dp stays the same, then you get a 0. You can make it into dp, right? Yeah. I'll just write an annoying 30 dp. No problem. This multitest is becoming annoying. Should put it in the template. Okay, then what? We have these 3 numbers. And I make just recursive, because why not? So it is small, big, tight, at. Okay, I want to do maximum, right? Yeah. Maximum number of items you can buy. this should return the maximum amount of items. Then what? I need a DP array. And a visited, just as stupidly as possible. Okay. How do I do it? This is annoying. I'll see. Then return 1. Exactly one way. Okay, now. So we can decide that okay, let's do just if type and this appears in X, make it untied. So what would happen then? So then we would try, okay, yeah, let's just loop the digit then. If, and just make some variables. And then what? XDay. If small and if big, yeah, this is just writing digit dp. This is not so interesting, but it just has to be done. Probably there's some easier way, but if it works, it works. Okay. If type and not d. So it has to. Okay, probably I need to return integer. Also make it big. Okay. Okay, I think I have some idea how to do it. Okay, so this is the recursive problem. I didn't do tight yet. Just tight. Let's see. So what is the either we can add to the sum of the two. If it's tight, we can decide to make it no longer tight. So then we put this. either take the sum of those or take the best. That is better. Return res. Nah, this has a little not so high chance of working. I need to check something. Okay, so this is a bit too high. It's gonna be 29. Yeah. And then just output the answer. And that should be it. But probably I get wrong answer. Too high for this test case. 2. I forgot and actually, okay, forgot an and condition. Yeah, now it works on the samples. I think that's that means I can just submit, but it's a bit. The samples are really trash. Come on, code forces. Okay. This is probably way overkill, but yeah. Please. No time limits. It's 30 times 2 times 2 times 2 times 2. And recursion. That's not great. I know that. Why is it hanging? Well, let's look in the standings. What should we solve? M probably. Okay, let's read M. This can get DLE maybe. I hope it doesn't. Tree problem, values, weight, okay, query. Value and was weights lie in the range this. Okay. This one can be very large, output it modulo that. Okay, so we want in the subtree, this is basically just a 2D range query. And we need to do it. So what is 2D range query? Can do sweep line maybe. All the weights, all the values are nice. We cannot divide by 0. Yeah, probably just a sweep line is the best way to go. But you need a segment tree or something. Technically you can do it with a family tree. That's not really better. Okay, it's in queue. Code force having some troubles. What else? Yeah, probably I don't want to do this segment tree now. Is this more easier to type up? Let's read it. Wrong answer, okay. That's it. Why? Did I make some mistake? Sum and best. Probably made a mistake, but I don't know what. multi-test. So why is it only on test 4 that it is wrong? That's weird. So it could maybe be overflow. But I thought the constraints were really low. Okay, so now I need to debug this. Okay, maybe, yeah, this wasn't great. These continues are maybe weird. So I'm saying, yeah. At most X. Let's just make some small examples. Like this one. This. Seems okay. This should be less, right? Why is it wrong? Bitwise more. Don't really want to debug this now because there's other problems to write. There's multi-test, but it shouldn't be a problem. Probably I need to write stress tests. I don't want to. This early in the contest. This makes sense, this code. What now? Camera is frozen. Oh, that's not great. Can I somehow... Doesn't work. Okay. I unfroze it, but I don't know how stable it is. Okay. What now? Probably I will just try another problem, come back later. Why not? This problem. Also constant size input. Why? Okay. Upper margin. Number of different complete notebooks that can be printed. What the hell? Our constraints. Oh, R is small, so we can brute force X. X and D, we can brute force D as well then, because then I think that would be easier. Yeah, I think we can brute force X and then this. Okay, so this is just a brute force one. Probably this is easier than L. I got trolled on L. Let's do 10 to the power 6, yeah, in 1 second. Should be fine, should be fine. And the inputs, it's not that big. What is this N? That's total. Wait, where's N in the statement? The writing area total. Aha, okay. So then we loop D. And then what? Then we know at the bottom. Okay, so we know N, not D. Okay. So X is some multiple of this. Is some. Okay, I think what you can do, R minus X divided by D. This is where we can place it. And then probably plus 1. Round it up like this. Yeah. Okay. These just work. Okay, this is way shorter than the problem L. I got trolled by the standings, but it's wrong. Okay. Okay, the thing itself, so we should do this. Probably should take a maximum here with 0 just to be safe. And it's too much. Okay. Okay, so now it's debugging time. So, okay, 10. So if D equals 1, D should be less than equal to X. Okay. Maximum it can be is that one. Maximum it can be is that. Yeah. Okay, it has to. Okay, I didn't use this constraint. That's probably bad. So it should be x less than L. So we should probably do L minus x divided and then round it up. X plus SD times this, such that we shift it above the L. Okay, 3, 6, 8. Okay, that works. And the camera also still works. Okay, I will just submit this. This should be fine with the time limit, I think. Yeah, okay, this was way easier than L, so it was maybe good to skip for now. Let's look in the standings. Sitting a bit further behind. Let's look at F. And this shit, okay, wait, 5,000. And this one, I just didn't get the statement. It's very, oh, it's in a note, that's not so great. It's obtained through this, okay. What do we need? Okay. So basically need to just rewrite this, because this is annoying. X or Y 2 times. And if we add it, it's less. Yeah, what is that? Okay, so I think it's XOR, right? Probably it's XOR. Should that... okay, and then... okay, yeah. Okay, we can write a brute force really quick to check it, and then we optimize the brute force. Is the... oh, there's no multitest. Okay. Is there Q? No, there's Q. We want maximum value? Yeah. Let's just do this. Hopefully this is correct, and then we just optimize it. Okay, it's correct. Okay. So then we make just a simple dp. How big was M? 5,000. Okay, so then we do over all the subsegments. We make it equal to this, and then we leave this. Compose, see out the dp. Made some mistake. Not great. I somehow removed the XOR itself. Just make it again. answers again. Submit this. Okay, nice. I'm not so happy about this L. Can we do another problem before we do L? What about J? Is divisible by integer? Okay. Okay. Wait, is there anything tricky here or not? Just to make sure that every subtree. Can we? AI. Print -1. Okay, I get the problem. I think there's only 2 options each time. You should just take the better option. Yeah, okay. So this is not so hard. And we do it in C++ because I don't want to do recursion in Python. Read this. Read the array. And there's weighted edges, right? Yeah. Make this. DFS. It should just return the subtree sum mod k, and then we add things to the answer, and we check at the end. DFS now -1. If the subtree sum of the whole thing is not divisible, then we set the output to -1. Output the thing. Oops, it's weighted. Now we have 2 options. We can either like move more units this way or this way. So we take minus this. Okay, and then what? Ans plus equal this times this. How big can the answer get? 10 to the power 6, 10 to the power 6, 10 to the power 5, 10 to the power 17 total. That's fine. Okay. Return this. Now the question is, did I make any mistake in my reasoning? Apparently not. Just submit. Oof, yeah, okay, so now the question is, Can you make something less than 0? Maybe that's the problem. But I accidentally make stuff less than 0. That would be bad. Or I've just, okay, I add the children thing. I forgot the mod k here. Is that just a problem? Oof. Why? Sad. So I forgot modulo. Just submit again. Oops. Accept. Okay. No, this was. Well, what are these people doing solving this problem? Yeah, okay, but my idea is not intended probably. But I cannot find the bug. So now it's dilemma what to do. Probably M at some point, but not now. Okay, maybe I should do one of these. What's this about? Low constraints. Okay. M problems. It's exactly this. Total score, ranked by total penalty, best. Okay, this is DP. And it's this must not. Yeah, this is just bullshit. I think. What is this? And how many hours are there? Is the total time in hours, and then you do this times 60. And what is DI? Okay, with time and what units is this? Okay, let's see. Okay, it's in minutes, so that's in minutes. So this is 5 times. Let's see. 5 times 60. 300 times 100, and then there's 100 test cases. Okay, that should be fine. So now just implement it. And there's one trick, of course you need to sort by these numbers. Okay. This one is really doable. Okay, what is h times 60? Here we do d divided by 50. Sort, and now do a sort of knapsack. Let's stay, and then dp of I and time used equals min, let's see, max points, min penalty so far. Because we sorted the d's, the greedy also works, so we put the problems in the right order, whatever subset we take. So now we loop over this. Okay, hopefully there's no reconstruction, right? Okay. So now is there reconstruction? One based indices. And I'll put one where lexigraphically smallest. Okay. That's annoying. So how do you solve the lexicographically smallest part? Because I'm sorting and then it's no longer lexicographically smallest. So for some subset, basically I can so okay, so this 100 I can basically like also do a subset stored in int 128, and I want the smallest, so I should kind of redo it. Okay, so I need an index here as well, so I change this id name. Okay. Okay, and then what? So a min max points. Then if there dies min penalty. Wait, what was the change on rent? If there are multiple sequences, output the one where the polymer indices are lexicographically smallest. Okay, wait. So this is not true. Okay, so maybe if I have an extra 100 factor, how bad is it? Okay, wait. I think I don't need this because they are in the order that I want them. And then maybe I need to make sure I do stable, so because I want earlier things first. Yeah. Oh, and I need to give a custom comparator. I only want to sort on this. That should work. And now I need to make a DP, and I need to store it and then backtrack it. And which way do I want to backtrack it? So maybe I will actually want to go in reverse order and then I backtrack forwards. Okay, and then I need the DP. How will I store a DP? Like this. How big can the penalty get? 5 times 60 times 100. Okay, that's really small. Scores are also small, so it should all be fine. So like, let's do this, and let's do a stored as points min penalty dp, and then what? N plus 1 long. Then it should be h times 60 plus 1 long, and then what is points? Where's this? And then we say, oh, I don't need this, times 60. Also, let's use the nicer syntax. dp of n0 is 0, 0, no penalty, and that's it. Okay. Now do I know that? Okay, maybe I should. Now I need to think. Yeah, probably I want this actually here. Okay, let's get this. Okay, this problem is annoying to implement, so maybe before we do this, let's think about what we want to solve actually. What is this problem? I didn't read this probably. Oh yeah, I read this. Maybe this is actually easier. 10 to the power 5 times 1000. Okay, so I need to answer these queries. Can there be like so now the question is and this one is also not so great to implement. I don't know if I actually have a good solution. Yeah, so maybe this one is not so great. What now? It looks like maybe I have to debug L now. M is also interesting. It's just so much work. How would I do it? So I make the DFS in order. I do sweep line probably on this. I have some events for the queries. And then I need to do range product and what else? Point addition. Well, just do it maybe. So now the question is, can I write the segment tree? I should be able to. Okay. Okay, query. Answer. Okay. And now I need to check. Now I need to think a bit. Then segment tree now. Yeah, okay, so this, it looks like a lot of work, but needs modular inverse though. Okay, let's write it. Okay. I have the queues. There's no multitest again. I can just do this. Send the queries. Uses updates. What should the query store? Yeah. Maybe 4 links. Okay, and then read everything. Value. Val. Okay. Then what? Then W's. This, I don't think this needs much. This can just be this. Update, so we do update at this thing. Okay, then we have 3. DFS in numbers, and I also need out, right? Values in the subtree, yeah. This, out, count, yeah, DFS. Okay, boom. This is all fixed. Now read in the queries. Now what should I read? Int ULR. Okay. Then this. Okay. News. Probably I need some less things than I thought initially. Like this. Queues. Pushback. UI1 -1. Now this feedline. Do all the updates first, probably. Now the question is, yeah, what? Yeah, do the updates first. Okay, then make the segment tree on the DFS order. Okay, so I did the update. Now do the queries. Query in you, out you. You get some result. If sign is -1, res is not x plus -2. And then we need an answer array. Ends of ID is no ends ID res, and we need to initialize it at 1. And then we output the answers. And now I should have made no mistake, and then it's correct. Yeah, it's wrong. Which 313. made a mistake in the segment tree probably. Still wrong. Okay, so now we're 1 1 1. This first query is okay. The second query is where it all goes wrong. What is the I currently? 0. I2. Okay, I think I forgot this one. Now there's infinite loop. Not great. Yeah, okay, I think I know why. Okay, so it works. Just submit. Did I copy the modulus correctly? Yeah. Accepted. Yeah, it's just like a problem you need to do it. Okay, what is this L? What am I doing wrong? Can I sort of... I can write a brute force, right? How hard can it be? Brute force should be easy. And then just write stress test. Okay, let's see how fast I can write this stress test. So I make a brute force program, delete all this. So we loop over the final OR. We loop over all the numbers if I and Y. Oh, I need to just. Oh wait, okay. Maybe I just. Did I forget something? Maximum number of items. So. Probably I will find some stupid mistake, but I don't know yet what it is. So let's run it on the example first. Totally wrong. Great start. LRX. Okay, so I think I messed up with the lower and higher things. No, maybe not. Okay, so this is already wrong. So that's a good start. Oops, are the floops. Okay, so this brute force is correct. Then I write some other stuff. Then I need to generator. Then what? I should run my brute force, run the fast solution first. And then here I should make sure okay. Boot, slow load out, slow load out, fast load out, if. Okay, now I need to make generator. Okay, just one test case for now. What's LRX is round int 110, 110, round int 110. If so it's just very small test cases, and hopefully I find a bug. Okay, that's not very encouraging. Okay, found the bug at the 300th test case. So what's this about? Two, three. So wait, so my fast solution. Okay, so my it's definitely wrong, but why? Start from a smaller place for now. Don't forget to change back. Okay. So what's happening? 4 and 5. Okay, so it's only. Hmm. 2, 4, okay. So it's no longer big. This tight. So which one is it? 1, 1, 0. Okay. So something with this logic is not adding up. But what? It's tight and. basically I can think about not tightening too and then do it wrong. Yeah. So basically this maximum is bullshit. So how to fix it? Maybe I just need to do just make it a bit bulkier even. Okay. So what? Min tight 1. If d is not xt, if tight is 2. Please, this should be the fix. It's very dumb, but okay, and then put this back up to 29. Run the boot for some more. Maybe let's add multi-test now. Run the multi-test. Still wrong. I made some very stupid mistake now. Probably it's wrong on the sample. No, it's not. This sample is very useless then. What do I want to do? Probably restrict these ranges even more. Just to get the smallest possible test. Okay, it's still wrong. Even now. 1, 1, 2. So what I'm saying is 0. Okay, that's nice to see that it's an easy test to debug. Let's change this again. Okay, yeah. Forgot this. Oops. That should be easy to fix now. Okay, let's crank this up. Let's do this a bit bigger. Let's test it again. And then let's add multi-test. Okay, no. Not needed. Still wrong. Oof. So this is saying 16. I'm saying 18. Too big. Okay, so I don't want to waste too much more time. I should just do something else. Okay, what the hell? Okay. Something like this. I'm not sure if I need to. Yeah, okay, let's just do it. Okay. Auto. just have the sum itself. You have the rest. Okay, and here you say don't need this anymore. Don't need this. Here I just want sum, and here I want the best one. Here I want just the sum, I believe. Or do I want the best one here? I think I want the best one there. Please, please. Oh. Sum too big, so I get overflow. Not great. Not great. Do I do something stupid again? No. This is also way too stupidly high. Okay, I'm very overcomplicating it, but should be almost there. But no cigar. Sunrise, sunrise, sunrise. Check faults, fine. But why? Am I doing anything differently now? Fuck. Okay. Okay, I could make this like this. Is that it? No. so slow on this one problem? Please, easy test case to debug. Yeah, this is easy to debug. Let's see. See if everything's still working. Yep. Maybe I just didn't compile. Get back to this test case. Wait. Huh? If okay, but now I hope I don't TLE because of slow code. Yeah, this works. Test it again. Still wrong. Poor. it's so low. Doing something bad. What am I doing? Okay, I think I can simplify my code. I think that's probably for the best. Yeah, okay, this code is just wrong. Okay, fuck. So how do I fix it? 2 seconds. I can try to do something like this. I just messed up really bad. I just need to basically rewrite the whole code. Okay, boom. And then I just do it with this one. And then just hope it works. now just simplify all this code. What now? Auto on as processed it. Pop, 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 pop. Okay, but now it could be slow. So hopefully now I can write and this should return int, and this type is no longer necessary. And this one gone. Return 1. Small constant optimizations. Okay. Let's do this. And let's run the stress test. Okay, so it's now correct. Is it fast enough? I think we can just submit and find out. Yeah, this took me a lot of time. Not great. It's just fast enough, that's annoying. Okay, so we have it. So what now? Is there any easy... Okay, so we have a whole streak that we don't have. Maybe look at this. Oh yeah, but this one I was implementing and then I stopped. And basically the hardest part is reconstruction. I think. Okay. Yeah. Okay. Just finish this implementation problem. Probably is the best thing to do now. The end is always better. Okay, yeah. So now just fill the DP table. So my duration, let's see, less than h plus j. dp of r plus 1j. Then what? Then I need to change the here plus the points here. Okay, and also I could do just nothing, so I think we need to carry over the DP array like this. Or I could increase the points, decrease the penalty. Yep, then what? And this one is okay, and then not min of that, so I need just a positive one, this min ID. Okay, and then dp I j minus d max dp I j minus. Good. Okay. Let's see. So it compiles now. Yeah, wait, now I need to quickly check. Yeah. And now only reconstruction is left. Great. So where am I now? Used. Okay. And now just check both options. If dp add used equals dp add design used, set else add. Put this in the end. What do we do again? We add that to the answer. I can just immediately output it and do what? Use plus equals d. Okay, maybe I was 2, 3, 2, 1. That works. This one also works. Why did I think this was so much implementation? It's pretty good actually. And now I just hope that I made no mistakes. The samples are probably also really bad. Yeah, shit. So what now? Okay, so wait, what did I do? Max points. Of course I want max points. If there's ties, I want min penalty. And that's why I store minus the penalty. And this is the moment I finish the task. Oh, and I made a mistake there. That should have been J. Of course the samples don't catch anything. Let's just submit again. Nice, accepted. And now I have to think, what do I want to do? Is there something specific, like this one or this one? How much time did that take? 1 hour 50 minutes. Maybe I do quickly close and have a break. Yeah, probably a break is good. back to reading some problems. This one I solved, this one I solved. Maybe read B. Nah, it looks too annoying. We did C. D is pretty short. You need to compute something. What do you need to compute? This range query with XOR mixed in, and everything is quite small, and time limit's really big. Yeah, and in 10 seconds. That's the sum over these things. Yeah, why not just write a brute force? Is there something you can do into brute force to make it better? Not really. Like you can try to write it unrolled yourself. Like probably this 10 seconds is just way too big of time limit. Like probably they had some nice solution in mind, but you're not saying to me that like you cannot just do n times q. So how do I implement it to get a nice speed up? I can try to write it like in steps of 4, and then hopefully it works. Okay. Okay, boom. There's no multi-tests. This, yeah, this is, yeah. So then I do, okay, well, that's and not 4 is not 0. Like this, and now it's aligned, and I can do some nice tricks. So what I will do is I will write a for loop, but in steps of 4. Okay, and then also I will of course use global array. And then what? Okay, now just write this, ans plus this. Okay. Okay, now I think you can do this. Ans j is ai plus j XOR k plus. Okay, and I need to read this, and then I want to just make it dependent on the index only. So I do this. Okay, and then there's still a problem. Not. No, I think that's fine. Okay. Maybe I make this worse. No. And now I need to write unroll loop somewhere. I think it's written like this. Bad option. Like this. Okay, maybe I just search it up 03, comma. Okay, so I should just do this. So there's no warning anymore. Let's just see that okay, I made some mistake. Okay, now let's for now disable this. Otherwise I cannot see what's going on. LRK, okay. Oh yeah, this is what's going on. And now the question is the unroll loops AVX2 strong enough to pass? I think I did my best. So let's just try it how it goes. It should be really fast. Okay, that's where all the small cases, and I think it passed at least one big case. Probably. Oh shit, no. Okay, it's pretty slow. But I think these are max tests, and if it passes one, it passes everything. It's a bit slow, yeah. But it passes. Nice. I wonder if I didn't write all this, if it would have worked. What I can try, just for fun, let's try to do this. Would that be worse or better? I think it could be maybe that the compiler itself is better than me at making this. Let's just do it again. Just to check, and I hope that doesn't give me any penalty. Don't think it does. It could be that this is faster. Oops, it is faster. Okay, so I'm not that good at optimizing it. Well, What's this about? I didn't read this before, I think. Okay, let's read it. Choosing k at each step. Okay, so you just want to have the highest. I think just having the highest health is always better, right? And you can increase, otherwise you decrease, yeah, and this bound only goes up as well. So you have more options. So then it's just about finding minimum and maximum. That's not so easy because the constraints are really large. Oh, this is weird. So yi is kind of small, but x can be really large. Okay, so maybe I'll just write some observations in the code. Is there multitest? Yeah. Okay. So now I have just this y and we need to deal with it. If x greater than or equal to y, else this. Okay. Let's think about it. So I think it's just casework. That's probably the main thing. So maybe I think this case is easier. So here we're losing health. If x less than 4, that's in the statement. Then what? There's nothing about when you die. If x greater or equal to y, otherwise it loses yi power. Just do it. Okay. Else. Okay, so how much power can we lose at most? Like if we take 2, so worst is 1. Okay, now we check. So within 2 until this, if there's a divisor of y. Okay, and y is not that big. And how? So we could, yeah, we just need to factorize like so many y's. Factorizing and then checking out divisors should be fine. But then we need to factor array and then do it. That's a lot of work. Is there something cheesier? Now the question is like the square root thing good enough? So let's calculate it. This divided by ln this if you do only primes. Yeah, that should be really fine, right? So we just get all primes. I was not really, I want to check all devices, so let's just delete this again. And then we need it times 2e5. That's a lot. That's not good enough, so basically we need to do it quicker. So we can prime factorize, yeah, maybe that's the easiest. We need to prime factorize anyway. Let's just have a factor array. Factor constant and 1.187 void sieve. Easy to write. So receive, then here we factorize. So we get the primes. Wow. Wow, y greater than 1. Factor y. Oh, y not 0. Plus plus. Oh, okay. And that's in pot. Turn. Oh wait, do we only need to check its primes? Wait. Like we want to check if there's a divisor of y which is in this interval. So we basically want as small as possible, so we can just only check the primes. Yep. Okay, so we just check it. If f less than equals to and then it's great, right? Okay, then worst is 0. And then we do x minus worst. So this case is done. Then we need this other case. This will probably be harder. Let's think again. So here we want to maximize how much we get. So how to do that? So basically if we choose some mod k, we can rewrite it to be y times if the x is really big, then we can just x is greater or equal to y. Okay. I think there's only one case probably. So if x bigger than y, if x times 2 is divided by 2 bigger than y, can get y itself. Else we can get at most half. How do we get it? Can we get almost exactly half? Half itself is not possible, right? But half minus 1 is maybe possible. How to check that? X greater or equal to y. If it's exactly, then we're a bit fucked. Okay, else. see here. Else nothing happens. Okay, but this should be almost always true, right? When does it not? When it's not true? Okay, if x less than 4, continue. Repeat it, right? So we need to have an answer array as well. So here, what else? Else we do. I think this is true. Let's work it out. So this is definitely strictly linear. Else k equals plus 1. K equals y of 3 plus 1. Into output. 9. Yeah, but it doesn't say anything. Can I somehow test it some more? I don't want this assert in my code, at least. What if it's wrong? X is greater or equal to 4. Else. Y is greater or equal to 2. Whatever, I think it's correct. Just submit once. I don't know. It's just a case of problem and factorization. I think I did those. Okay, this is maybe a bit not needed as well, but that's very fast anyway. Why not just try it? Okay, I have a new message, but I will not open it here because I don't know what the message is about. Okay. Two left. So what did I read even this problem? Oh, this is this problem, yeah. I procrastinated this problem for a long time. Okay, but okay, and offline queries, yeah, okay. I think the main observation is here that there's only 1000 palindromes that are important. Like square root of 10 to the power 6, basically. Even much less, actually. It's like closer to, yeah, closer to hundreds. Okay, but it's few. 2000, something like this. I can loop over all of them. And then I need to find like pairs which sum to this one. And I can do an entire loop, but then these queries are very annoying. Like, how do I do them in a good way? Basically I have some minuses, I have some pluses. I need to count like the number of pluses times the number of minuses. But they're all different. Okay, now I can think about like maybe it's just like Mohs algorithm. Because when we shift one of these outer elements, we can just update the sum, basically. And then each update costs maybe 100 or 1000 steps, so that's not that great. Because it could be inside a lot of those. Could it though? Probably it can. Yeah. So maybe I just first need to check what is this maximum amount. Then I can make some estimates about how fast the code will be. Okay, whatever. So yeah, let's just do it. There's also no multitest. I would guess 1500. Let's see what the actual number is. 3000, okay. Fine. But not great. So every update of Mohs costs 1000 steps. So if you calculate, I don't think it's better than just brute force. $3,000 step update. But if you have the larger, yeah, okay, yeah, it could be a bit less, but then times square root only 5. Yeah, it's way too much. So we need something else. So basically for the entire array I can calculate it in 3000 times n. But the range queries are too bad for now. So what if we do sweepline on R? Then when we are at some R, we need to do some updates. Basically, yeah. But there could be too many updates. I have like big ones and small ones. Okay, but I can group the numbers, this AI, into small groups and big groups. Then what? And then make it like really one way. So let the big groups, okay. So let's just write down what I have to say. Do sweepline on R. Make a family tree to answer the queries. Maybe square root 3. group or small group, do something. Small group, loop everything. Big group, update the entire, update the data structure. And what is this data structure for big group? Small group, like just family tree or something is fine. Probably blocking is better, so I should do blocking. Yeah, so no, do blocking. And then for big groups, basically I need to say, okay, for all these numbers to the left of me, I basically need to do plus equal 1 on a group on all these numbers. Okay, but and then what else? So it's basically range update. And if you do coordinate compression, and coordinate compression, and then we have again some good data structure. Like here, maybe family tree is best. Range update is plus equals 1 on a suffix, yeah. But yeah, okay, so it's range update, range squared. So I can also, yeah, I can maybe do it with a segment tree I already have. And then the trick is balance it well. So the time complexity becomes n times p. Let's call p is number of palindrome, n times p for the small, plus then log of n, which where this log is not so great, q times square root n plus n over b times log n. And now we should balance all this. So what are the worst case terms for me? I would say, so this b can be quite, yeah, so that cannot be too big. So if we take, I think this one is the blocking term and this one is, okay, so if you think about that, that's 1e5, why 1e5, so I have 1e5 times 1e5 times 18, that's this right side, and then this is the left side. Then we do this divided by 1e5 times 3000. And then we take the square root of this, and this is our block size. That's not too great. Especially here I could be fine with, no, I'm not fine. So what is the final complexity? You can just calculate one side. 1e5 times 1e5 times 85, but it's not great. So this is not good enough probably. They have only 4 seconds, but they have a lot of memory. And there's B. I'll get something to drink. And then read B. Okay, this also looks really annoying. Clearly also data structures, because of these LR queries. But I could see that you maybe also need some observations. Work still. Stream is still running. Okay. Something to do with the bits. But there, okay, so one observation is that I can kind of find all ors and all the subarrays in like n times log a. In an implicit way. I don't think that helps that much. I would have liked it much more when this x was a constant instead of different for every query. That makes it hard. Okay, so this problem is like way... Here you can have some insights at least, and that problem is just really hard. I think these palindromes itself, they are just pretty bullshit. I don't think you can get anything smart out of it. You can just treat it as 3000 numbers. I wonder why that number is still so large. Ooh, okay, I think I missed something. Yeah, okay, I can see now. Can I just optimize that thing? Okay, what if I do just a range pass for every there? It just seems really hard. Or do I need to do some clearly really hard segmentry? Don't know exactly what would be best. Okay, like Mose is really easy to write, but it's probably Tili, right? Can you do something else? Like you kind of need to loop over all these palindromes. So that's kind of just not it. Can you do some? Something FFT. How would I go about that if I would like to use FFT? So for each block you could run FFT, but this is slow. FFT is also, it's very slow. I can kind of pre-compute for each AI with which palindromes it's even useful. Okay, I think there's some cheat solution with Mose. You just do Mose and you pre-calculate like kind of all edges between value AI and AJ, only if they appear in the end values in the input. That could reduce the number of pairs a lot. Basically by a factor of 10, let's say, because the B's are pretty random. So if that's true, let's say you cannot prove this, but let's just assume it's true. You get about 300 pairs per number times 25 times square root 25. It's still a lot. Why? But if I do it in my other solution, okay, so if I plugged it in my previous solution, wait, did I use that there? Yeah, I did. Stupid. Let's do it again. So then the block size decreases even more. But it's only like it's not even a 2x speed up. It's 300. That's so annoying. Still, is the G's possible? Your code also says like you say LR and divide it into some cases. Maybe cases is easier. You take one in R, and then you subtract 1 in L, and then you should subtract this. Yeah, this last step is maybe hard. I can just try. So, nah, this doesn't really help. Stupid 3000 factor. So I have some G solution and it will time out the problem. Because like even if I estimate it very optimistically, I get this. But maybe the test cases are bad. Maybe. And then this is much less. Could try that. Could try that. But like even if you take a random, if you take these randomly, then with each of them there's a 1/10 chance that you have a hit. Like with the random, this is already 300. So no. make some calculation mistake? Yeah, probably I did. Okay, let's try it again. Okay, so it's 77 now. This kind of speed. I have just some pairs. Is there some constraint that they're distinct? No, there's no such constraint. But I think that is a good thing. I think I have some idea. Basically for that one, if I pick, I store all small ones. I just loop over all small ones. I do it in one way and the other way. And then take the sum of them and use a block data structure. Yeah, this could work. Okay, I think I have a solution. Let's put this at the top of the program. I'll just try to implement it. Okay. So what was my plan again? I'll loop over the smaller of the two. But do I still need? I think I made a mistake. made some mistake. I was a bit too optimistic with my solution. Yeah, these last two problems, they are not so fun. I think I'm still in the lead, probably. But yeah. The last two are way harder than the rest. I'm not sure what to do here. Yeah, I think that's just the same solution again. That's not what I wanted. plus 1 voor alle. Daar zijn dingen die gelijk zijn. And this one is the shitty problem. Don't like this problem at all. Okay. Okay. Can look how fast this code is that somebody submitted. I think it would probably be interesting to know. Where is it? Maybe refresh. Yeah, okay. So how fast is it? Very slow. I think maybe I should just do the most and hope that somehow it passes. Just feels bad. Okay, maybe something else. So now I'm stuck with a too slow approach on N, and for B I haven't really thought about it. So what is the next step? It's also pretty late. Do I want to keep going, solve them? For N I need to find some G's. I'm not sure if there's a legit solution. Assume the input data is random. Yeah, I think I'm gonna just try it. I don't know what else I could do. Can I just try? So what would I try? passeren. Just try it. I never know when you don't try. So what I will try now is okay, boom. So now we have an add function nodig straks. Add delete. Okay, wow. Okay, now boom. En ans van. Boom. to lose. Can maybe Wagma at the top, but probably it's DD. Unless some other test cases are very, very bad, but don't think so. Shit, DD. My random max test as expected. Yeah. That's bad. What's the block size now? Basically good block size. Bruh. This is just too slow. How many edges in total could there be? I would expect 3 E7 edges in total. Can you do something like split into big and small adjacency? Tune. Okay, so what I will take the biggest. So how big? Okay, less than equal to 50, let's say. Have them separately. So let's just think about how to do it. So if and then F is big for E. this thing. Okay. But then now I need to do some updates. How to do the updates? Okay, maybe I need just. That's maybe good to have. Mask van y equals okay. I made it slightly faster, but probably not by much. Because probably yeah. And it's wrong now. Like think about why it's wrong. This is fine. This is fine. this is not fine. Okay. Yeah, I don't expect this to help much. Maybe if the test cases are bad. So basically it's just more cheese. But yeah. Time limit on the same test. And try to tune this a bit. Maybe I want to even less. But nah. Don't think so. So I'm just stuck with a too slow solution. It's not even much better. Can you do anything else? Is there some nice properties of these numbers? That's maybe a good thing to ask. Something which could make it a bit easier. Just seems undoable. Okay, so this one we quit. Let's try this one maybe. Once again, data structure heavy. I think I actually have an idea for this. I think you could solve this using linked tree, if I'm not mistaken. But then I would copy paste that. Linked tree. Binary search, yeah. I could also square root decomposition. These updates are a bit annoying. Okay, so I think I have some ways into this problem, that's at least good. Yeah, so I can sweep line this. Okay, there's some sweep line you can do. So we sweep line on X, and for each R we find the first index L such that this OR is greater or equal to X. This I can do, and then I basically have some problem where you have some edges you basically kind of have some tree, I believe. Yeah, it's basically just a tree. You have a tree, find the distance between two nodes, but the tree has updates. There are a lot of updates. That's maybe annoying. So is square root n times square root n times 30, is it good enough? Don't really think so, but could be. And then otherwise it's n log n times 30. Yeah, but I think it's, yeah, this one is more standard than n. They're both kind of standard, but and I just don't know how to optimize it. Well, here there's a pretty clear n log n solution, but it requires linked tree, so it's not too great. But I will just copy paste linked tree. Hopefully this one is easy to use. It should be. Okay, boom. Back to VS Code. This is the wrong one. This one. Okay. Is it doing something? Okay, I have a big code. Is there's no multitest again. So it's basically just a bitwise part and then a linked tree part. So we have some updates. So we have L, R, bool is update, and X. Operator. Okay. If X is open X, return is update. I want updates first and then queries. Otherwise, return X bigger than this. Okay. Then I have a parent array. Initially, I'll parent go to there. Okay. Then I have a linked tree plus 1. Link. Okay, I need to rethink how to use this. Okay. Okay, boom. Now I need to make all the events. First, let's just read the queries. Did I read? I don't. Okay. Read the queries. Okay. Okay. That's everything. Okay. Now I'll sort here. is kind of straightforward. Yep, just do that. Maybe less straightforward is this thing. Then what I want, okay, how are the nodes? Okay, just access. Okay, ik kan gewoon access doen. Tree.access. Okay, tree make root. Okay, next tree.access. And then okay. Okay, boom boom. Oh, great. And now I'm probably the rightmost. Want to find, yeah. Find the splitting point. Okay, then let's display. Going to be some publishers. probably missed this message for a long time. I don't know. I think the last two problems are way harder than the rest. I think I know how to do B. I'm not sure how to do N without cheese. I'm really unsure what they wanted with problem D with a 10-second time limit. Like just for loops passes. So that's a bit weird. And then for the rest it was okay, I guess. Not very special. Currently implementing B. Having some troubles with my link tree template. I think there are some ways where I can make my implementation simpler. Okay, so I will probably not use that. Wrong way around all the time. Poof. Good. No, I don't like it that much. I think I will stop the stream. I'm not sure if I will finish this implementation, maybe in my own time. Yeah, thanks for watching everyone. I think this is just, it became a bit too boring now.